So we're going to look at 1.4, which is perimeter and area in a coordinate plane. So just to kind of refresh your memory on what a coordinate plane is, so get a pen up here. This x-axis, y-axis, that's your coordinate plane. So we're going to be graphing some polygons. So polygons are just many-sided figures. For example, the smallest polygon is a triangle. Then quadrilateral. And we have varied types of quadrilaterals. Pentagon is 5-sided, hexagon is 6-sided, heptagon is 7-sided, and so forth. We're really just going to stick with quadrilaterals, and we'll talk about why in just a few minutes. Before we do that, our book assumes we know some basic area formulas, so we're going to go over those really quickly so that we're all on the same page. So the area of a triangle, and this is the symbol for triangle in algebra. So the area of a triangle is half base times height. You could also just do base times height divided by 2, which is the one that I tend to lean to is the second one right here. Area of a square, rectangle, they're all the same. We kind of differentiate for square, but if we just use the same thing, is length times width. So we're just going to find the length and the width, and we're going to multiply, and that's our area for a square. After that, we are going to have some trapezoids, and so you can use the formula for the area of a trapezoid, but I actually do it a different way, and I'm going to show it to you on the next slide. But the formula there is half the height times the sum of the bases. And so that's kind of a long formula. And so, like I said, we're going to talk about ACT quite a bit because 20 out of the 60 questions are geometry. And so I just want y'all to be really prepared when you go in to take that test. So I'm going to actually show you a way to do it without having to go in with a lot of formulas. If you have some basic formulas, in fact, if you have these two formulas right here, it's a terrible eagle bracket. If you have these two formulas right here, you basically can do any shape on the ACT. And I'm going to show you how to do that all year long, but particularly I'm going to show you how to do it on the next slide. So let me clear this ink and let's go to a mouse and go to the next slide. All right, so we're going to find the area of and the perimeter of this figure right here. So we'll start with the area first because that's going to be the more basic one. Perimeter comes from two words, peri, which means around, and meter, which means measure. So we're actually finding the measurement around something. So the around measure. Basically, if I let's say I started here and I walked over to E and then to D and then back to G and back forth to F. How far did I walk around this shape? That's the perimeter, okay? But we're going to start with area. So I'm going to take this figure right here. I'm going to drop a line down right here, and you can see after I do that, I actually have two shapes. I have this either square or rectangle. We haven't counted the sides. And I have this triangle. And so that's what I was telling you. We can take any shape. Oh, it's terrible. And we can break it into rectangles, a series of rectangles and triangles, and find the area of those and then add them together. So it really basic. When y'all learn to do area in elementary school, your teacher had you count these squares and you went 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 10, 11, 12, 13, 14, 15, 16. And so the area was 16. But much faster than that, you can see that the length of this side is 4. The length of this side is 4. 4 times 4 is 16. So that was really fast. On a triangle, I really can't count the squares because see, I have like a little part of a square, or yeah, I have a square here and a little part here. So we're going to do the formula of a triangle, which was that base times height divided by 2, or half base height. So the part that is perpendicular to each other, like there's a right angle here, that is your base and height. So this base is 2 and this height is 4. So we're going to do 4 times 2 divided by 2. And I like to cross reduce just to make it faster, but I could have said 4 times 2 is 8, divided by 2 and get 4. So the area of this whole figure is 20 because I'm going to add 16 and 4 together. And we don't know how many units is, so we just put units squared. Okay, that's how I would find the area. Now we're going to go back and find the perimeter. So I'm going to clear my ink. Remember we said the perimeter is just if I'm walking. So if I walk here, that's 4 units. If I walk here, that's another 4 units. If I walk across the bottom right here, 1, 2, 3, 4, 5, 6, that's 6 units. And then this one I can't tell because it's kind of like, crooked. So what I'm going to do is I'm going to do the Pythagorean theorem. So this is 4 and 2. And I'm going to find this by doing a squared plus b squared equals c squared. So I've got 4 squared plus 2 squared equals c squared. So 16 plus 4 is 20. And so I need to do the square root of both sides. So I'm going to pull out my calculator because this is a decimal. So the square root of 20 is 4 down here, 4 sorry, my pen is messing up, 4.47. You can round however your teacher requires you to. So now I'm going to add up the perimeter. I've got 4, 4, 6 all across the bottom, and then this is what we just found right here. So 4.47 right there. And so then I'll add that up. And I get a perimeter of about 18.47. ACT is going to have this in a radical. So when they have this root 20, they'll actually simplify it in radical notation. So that would be 2 root 5. And then you would have to add it to this. So this would actually be in ACT type of an answer. It could be, 14 plus 2 root 5, I believe. And so if I typed 14 plus 2 root 5 in my calculator, I'm just checking myself to make sure I did it correctly. Oops, I did something wrong. All right, I get 18.47, so I did do that correctly. Okay, but you can always get the decimal and then take your choices that are given, the multiple choices, and convert them if you need to.